Okay. Let's try and figure this fucker out. So I've been here for a bit trying to figure out why we are having a flame failure error on an engineered air makeup air unit. Over here is the fan. That's what fire's supposed to happen. And it's just being a dink. So we have flame failure. So this is future me explaining what I had done, because I don't think I explained that very well. I had cleaned the flame sensor, confirmed we had airflow, reset the unit a bunch of times, had it fail in front of me a few times, checked for gas pressure, confirmed I had voltage at my pilot valve, confirmed main valve had good gas pressure, confirmed my ignition controller was working properly, and that all my switches were opening and closing, and that all my connections were good from flame sensor and igniter, etc., to all the other components. So with flame failure, I can reset fire on and off without hitting this reset button or turning it off and on and waiting forever by turning this dial, the ambient control. Right now it's about 10 degrees outside, so I turn this dial up. The temperature is lower than whatever I set it at. Will activate flame. The pilot valve will open. We'll make a small fire in the burner. The ignition controller will say, hey, I got fire. And then the main valves will open and modulate a big and small flame. We have a manometer hooked up to our pilot valve. We have a voltmeter on DC volts hooked up to test points for our fan wall ignition controller. If this shows volts, then I know I have fire. If this shows pressure, then I know I have gas. So what I did is way around here. If we follow the pilot tubing from the pilot valve, we can get to the backside of our igniter through this door. That silver tube there is our pilot tubing going into our igniter and flame sensor. And yeah, I guess I'll crawl back in here and give you guys a closer look. It's so dark. Alright, so pilot tubing goes up into here. Air from the dampers that are supposed to be open behind. Air is rushing across our burners that way, where the fan is. Air is actually being mixed right here with the natural gas going through this little tube here, sparking here, making a little fire, being sensed, and then main valve opens. I'll show you what the igniter and flame sensor looks like. There is our flame sensor and igniter. The igniting happens here. Flame sensor is the big rod. So, to fix my problem, I undid this nut, put my finger over the top of this, and blew in that hole. I blew in that hole right there. And out that hole came a whole bunch of shit. So, tech tip Tuesday, put your mouth on stuff and blow. Right, then we'll turn you back on. Test it again. I think we're good. On! To go over a little slower what an engineered air makeup air will try to do when it's turning on is the outside air damper will open really, really slowly. There will either be an end switched or a timed determination. When the damper opens enough, the fan motor will start. And there's this guy in here. That will turn on. And at that point, exhaust fans should turn on and we're good. If, for whatever reason, it wants to heat, for this specific one, the ambient temperature is lower than 18 Celsius, it will try to heat. Trial for ignition will activate. Fan wall ignition controller will spark, sense, and monitor flame. Pilot valve will open. Gas pressure will be present. Flame will be sensed. Main valve will open. And the final valve will modulate that flame to maintain a specific discharge air temperature. Okay, fan is on. We're going to turn on heat. Trial for ignition. Ignition controller activates. Pilot valve opened. Gas pressure rose. Flame was sensed. See it again, slower. Off. Right? No flame sensed. Very little gas pressure. Here, let's do this. Zero it out. There is air going across this tube, right? So it will have some back pressure. So, on. Trial for ignition. Ignition controller activates. Pilot valve opens. Bam. Flame is sensed. Main valve has opened. Flame is now happening. We'll do that all again, but while we're looking at the flame. Heat on. Pilot trial for ignition. Pilot valve is open. Flame is sensed. Main valve opens. And then we modulate to maintain a specific discharge air temperature. Woo! Done!